Hi all, in this final part of kinetic theory of gases, we're going to see the internal energy of gas molecules. In the previous segment of kinetic theory gases, we have seen the beautiful scene of root mean square speed of molecules, and now is about energy carried by the molecules. Generally, internal energy U is equals to kinetic energy plus potential energy. For an ideal gas, internal energy of gas molecules U equals to K, where potential energy is negligible due to intermolecular force between molecules is negligible. This is the assumption that has been made in kinetic theory gases, so the potential energy is negligible. So internal energy U equals to kinetic energy. Kinetic energy is kinetic energy of translational. Translational is moving in one direction or in straight line. But the general equation for kinetic energy half mv squared. V is the root mean square speed of the molecules. So you have three options. You can choose one of these to substitute here in this V. So I'm going to pick this, and I will get the kinetic energy translational is 3 over 2 kT. Once we know that the kinetic energy of translational is 3 over 2 kT, so now we can state the principle of equipartition of energy. It states that the mean or average kinetic energy of every degrees of freedom of a molecule is half kT. It means the kinetic energy of translational, which is equals to 3 over 2 kT divided by 3, because of three axes x, y and z in three-dimensional. Once you divide by 3, you will get half kT. Therefore, the mean or average kinetic energy per molecule is equals to F over 2 kT or mean or average kinetic energy per mole, which is equals to F over 2 RT, where F is degrees of freedom, T is absolute temperature. What is mean by degrees of freedom? Is defined as a number of independent ways in which an atom or molecule can absorb or release or store the energy. The number of degrees of freedom for monoatomic gas like helium, neon and argon is 3. 3 is the direction of translational motion where contribute translational kinetic energy as shown in figure below. Now we can see the monoatomic gas like helium is moving in three directions of translational motion in x, y and z axis without rotating and vibrating. So the number of degrees of freedom is 3. For diatomic gas like hydrogen, oxygen, nitrogen, the number of degrees of freedom is 5. A diatomic molecule can have kinetic energy of rotation about any axis at right angle to its own. Motion about these axes are independent of each other. Translational motion in three axes x, y, z, so it is 3. Rotational motion in two axes y and z, so it's about 2. So the total number of degrees of freedom is 5. For polyatomic gas like oxygen, water, carbon dioxide and ammonia, the number of degrees of freedom is 6. A polyatomic molecule can have kinetic energy of rotation about 3 mutually perpendicular axes. So the translational kinetic energy is 3, the rotational kinetic energy is 3, so altogether the number of degrees of freedom is about 6. Degrees of freedom depend on the absolute temperature of the gases. For example, diatomic gas like hydrogen. Hydrogen gas have the vibrational kinetic energy as shown in figure 15.9, where contribute 2 degrees of freedom which correspond to the kinetic energy and the potential energy associated with vibration along the bond between the atoms. When the temperature at 250 Kelvin, the degrees of freedom F is equals to 3. If the temperature between 250 and 750 Kelvin, the degrees of freedom F is about 5. And if the temperature is greater than 750 Kelvin, the degrees of freedom F is about 7. So the degrees of freedom depend on the absolute temperature of the gases. Conclusively, the internal energy U is defined as the sum of total kinetic energy and total potential energy of the gas molecules. And it is crystal clear the intermolecular forces are assumed to be negligible, thus the potential energy of the molecules can be neglected. Thus for n molecules, U equals to n times mean kinetic energy of K, where U equals to F over 2 nKT or U equals to F over 2 nRT. Whereas for n molecules of monoatomic gas, the number of degrees of freedom F is equals to 3. So we will get U equals to 3 over 2 nKT or 3 over 2 nRT. Thank you for watching this video. Thanks a lot and thank you to the Lord.